Welcome, everyone. This is Creating Accessible React Native Apps at AxCon 2022. So in this talk, I'll be sharing insight into testing and implementing accessibility best practices for React Native apps. My name is Scott Winkel. I'm an accessibility specialist at Shopify. I'm a bald white man with a little bit of chin hair. I'm wearing glasses and a red and black plaid shirt. And behind me is a wall of DVD movies and a large screen television. You can find me at swinkel on Twitter, or my blog and online store is at scottwinkel.me. So back in January of 2020, Shopify publicly announced our adoption of React Native. This meant that from this point forward, all of our new mobile apps would be built with React Native. And by extension, this also meant a new learning opportunity for our accessibility team by way of testing apps and guiding design and development teams to create accessible user experiences. Fast forward a few months later, a few volunteers from Shopify start working on a new React Native app called COVID Shield. The COVID Shield is a COVID-19 exposure notification solution, which uses the exposure technologies provided by Apple and Google. And while the team at Shopify was working on this app, I was contacted by one of the leads and brought onto the team to conduct accessibility testing and as development was taking place. So what I'll be covering here today includes details on how I tested the COVID Shield app, some of the more interesting issues that I found, and the related solutions to those issues. But before I do that, it's worth noting that COVID Shield was eventually adopted by the Canadian federal government to provide Canadian citizens a notification method for potential exposure to COVID-19. And the app was rebranded as COVID Alert, and development was taken over by the Canadian Digital Services team. So some of the more specific topics we'll discuss includes what is digital accessibility? Who are we including when we talk about accessibility? What assistive technologies are available? How to test using mobile devices and simulators. I'll review some React Native specifics, that is issues found while I was testing the COVID Shield app. And at the end, hopefully we'll have some time for a few questions. So to start off, what is digital accessibility? That's a great question. Let's dive in a little bit. So simply put, digital accessibility means building digital content and applications that can be used by people with disabilities. These techniques can be applied to websites, mobile apps, desktop apps, operating systems, video games, and much more. So for some statistics from the 2020 Global Economics of Disability Annual Report, there's an estimated 1.85 billion people who identify as having disability. And this number does not include those who may not identify with having disability, so the total could be even more. And the disability market influences over 13 trillion in annual disposable income. And that's some serious spending power, which should not be ignored. And as the world population grows, so do the number of people with disabilities, as well as the total amount of disposable income. So who exactly are we talking about when we say we need to make our digital products accessible? Who requires digital accessibility? People with disabilities. And there are many types of disabilities which need to be taken into consideration when creating digital content. So at a very high level, some disabilities include visual impairments, people with low vision, color blindness, or who are blind. Hearing impairments, people who are deaf or hard of hearing. Cognitive impairments, people who may have difficulties processing or understanding information. Or motor impairments, people with physical disabilities. So these represent only a few disabilities at a very generalized level. There are many more than this, including other permanent disabilities, but we shouldn't forget about temporary or situational disabilities, such as a broken arm. It's also worth noting that disability is not binary, meaning it isn't always all or nothing. So someone who's blind may still have some vision, they could still be able to see to play a video game with accessibility options enabled, for example. Or a wheelchair user may still be able to walk very short distances, but it could be difficult or even quite painful. Thus, they rely on their wheelchair to live more independently. So how do disabled people use technology to consume digital content? So digital content can be consumed by way of assistive technology. There are a number of assistive technologies and devices available, some of which include, but are not limited to, screen readers, which audibly read out content to the user. Keyboard-only users are people who are unable to use a mouse due to a visual or perhaps a motor impairment. Screen magnification software or hardware tools help by magnifying the screen to high levels for people with low vision. There's also voice dictation software, which allows people who are unable to use a mouse or keyboard to navigate by voice. And there are many more forms of assistive technology input methods. These are just a few examples. So far we've covered people with disabilities are able to use modern technology via assistive technology, and the fact that there is a large market share available by creating more inclusive experiences. So what this comes down to is people with disabilities have the right to access goods and services, both in the physical and digital world. They want to be included, feel connected, and find their place in the greater community. And on my screen here, there's a picture of a man sitting in a wheelchair while body surfing on a crowd of concert goers. So I really like this quote from Annie Jean-Baptiste, who is the head of head of product inclusion at Google and the author of the book, Building for Everyone. So she writes, "We need to build for everyone, with everyone, not only because it's the right thing to do, but also because it drives innovation and growth, while making the world a better, richer place." So the next question is, how do we as designers and developers of the web and native mobile apps make sure our products are usable by everyone? How do we actually make things accessible? Well, by testing and doing a lot of testing and knowing what to watch for. So understanding how to test with assistive technology and meeting the expectations from people with disabilities is a big part of creating usable and accessible experiences. So knowing if something is accessible can generally be summarized in these 3 questions. So first, what is this thing? When someone encounters something on a screen, it could be a form field, a link, a button, an image, there needs to be information included to share context and understanding of what the thing is they're currently interacting with. This information comes in the form of the element's semantic meaning and programmatic details added by the developer. So semantics are made up of the element's role, name, and state. The second question, what happens when I click the thing? For the oral user experience, that is, in this example, what a screen reader user might hear, this is typically discerned via details from the previous question, the role, name, and state. So affordances, or hints as to what might happen on click, are based on the visual and oral user experience. For example, clicking an interactive control with a link role and the name "Read More About Knitting" would likely open a new page to content about knitting. So these details, the semantics of the control in question, which supplies the oral experience, as well as the visual affordances, provide hints to the user to what may happen when they click the control. And this leads to the final question. Did clicking the thing meet my expectations? So in other words, did activating the control result in what the user had in mind for when they clicked? Was the user successful or not? Coming back to the previous example, did clicking the link with the name "Read More About Knitting" bring the user to a new page about knitting. So being able to meet the user's expectations is very important in helping the user feel successful. Without this feeling, self-doubt may sink in. The user may start to question the quality of the app they're using, or perhaps blame themselves for not understanding how to use the app. Neither case is a desirable outcome. So we want to help guide our users to success, feel comfortable and confident when they're using our apps, and even better, get them to a point where they want to share it with friends and family. Word of mouth review is very powerful. So the point is, if all of these 3 questions and conditions are met, understanding what the thing is, knowing what to expect when the thing is clicked, and having user expectations met, if all of these were answered in the affirmative, it's a pretty good indicator that the thing is accessible. Okay, so let's get to this. I want to take everyone through enabling the screen reader available to them on their mobile platform. So in terms of React Native, which we'll discuss shortly, these next few steps will be useful when you've got your app up and running on your real device. But before we start, it's important to understand the basics of using a mobile screen reader. Otherwise, you may get stuck and not know how to return to the previous state. Both iOS and Android feature a similar base set of gestures when it comes to navigation. That is, finding and interacting with a control on the screen. So there are 2 basic methods. One is the explore method. So this means you would place a single finger anywhere on the screen and drag it around in order to discover content. This will cause the screen reader to announce the item which is currently under your finger. And you are free to explore in any direction when using the explore method. Number 2 is called swipe. So you'd use a single finger to swipe right anywhere on the screen. This allows the screen reader to locate and announce content items on the screen from a top to bottom, left to right sequence. And swiping left will find items in the reverse order. So once a piece of content is in the screen reader focus, you'd like to double tap anywhere on the screen to activate that item. This is important to remember, especially when attempting to disable the screen reader. So every iOS and iPad OS device comes with a screen reader called VoiceOver. To enable a VoiceOver on your iOS device, you go to Settings, Accessibility, and then click the VoiceOver switch control. If you're successful in enabling VoiceOver and you'd like to turn it off, remember to use a single finger and drag to the VoiceOver switch. Focus on the control and then double tap. And a little tip here, in order to save time while testing, you can set up your device with a shortcut for turning VoiceOver on and off. To activate this feature, you go to Settings, General, Accessibility, Accessibility Shortcut. So with this enabled, you can now turn VoiceOver on and off by triple pressing the iPhone or iPad home button. For Android, most Android devices come with a screen reader called TalkBack. If your device does not have this available, you can install it from the Android Accessibility Suite. So you can start TalkBack. Starting TalkBack may differ slightly depending on the Android phone manufacturer. For Google Pixel-based phones, you go to Settings, Accessibility, and then click the Use TalkBack switch control. And another tip here, in order to save time while testing, you can set your device with a shortcut for turning TalkBack on and off. So to activate this feature, go to Settings, Accessibility, TalkBack shortcut. So again, with this enabled, you can now turn TalkBack on and off by pressing and holding both volume buttons. So for iOS users, while you're testing with VoiceOver, here's some common gestures. To select and read the current item, you would touch or single tap. Activate the currently selected item, double tap. Move to the next item, swipe right. Move to the previous item, swipe left. Pause or resume reading, 2-finger tap. Scroll up is a 3-finger swipe up. and scrolling down is a 3-finger swipe down. So there are more gestures available than these, but these would be quite common in conducting simple tests. Coming back to Android, while you're testing with TalkBack, here are some more common gestures. So to select read the item is a touch or a single tap. Activating the current selected item is a double tap. Move to the next item is swipe right. Move to the previous item, swipe left. Scroll up is a 2-finger slide up. Scrolling down is a 2-finger slide down. So testing on real-world devices is really great when your app is in a good state to do so, but ideally you'd also be testing as you're developing the app. So let's go over what testing methods are available when you're working on your app in the iOS simulator or Android emulator. One method of testing your app in the iOS simulator is the macOS Accessibility Inspector. So the Accessibility Inspector is a tool much like the web inspector found in any modern browser. You can use it to inspect specific pieces of the app UI to test for things like component label, role, or state. And there are 2 methods to open the Accessibility Inspector. You could go to Xcode and then open Developer Tool and then Accessibility Inspector. Or use the Spotlight search and type Accessibility Inspector. To use the Accessibility Inspector, click on the crosshair icon, which is also called the Point Inspection button, and then use the mouse to hover over the UI to be tested. There's a lot of useful information in the basic section of the Accessibility Inspector window, such as the component role and name. For more advanced information, like the component state, you need to open the advanced section of the window. So for example, in this screenshot here, I was inspecting a button control in the COVID Shield app, which would show and hide the main navigation menu. The label in the Accessibility Inspector revealed the button's accessible name included all the content in the navigation window, which you can probably imagine was way too much information. So instead of a short and clear label, so that was definitely an issue to be addressed. The other way to test your app while in active development is by using macOS VoiceOver on your desktop. While VoiceOver is not available directly in the iOS simulator, it is possible to run VoiceOver from macOS to test your app. So to do this, you set keyboard focus on the simulator window and then enable and disable VoiceOver using Command F5. From here, you'll be able to use the virtual cursor to move between items on the screen. And to move the virtual cursor, it's a matter of pressing Control, Opт, and then either left or right arrows to move between content items. You can also test using gestures in the simulator. You can pinch, zoom, swipe in the iOS simulator by holding the Option key and then clicking and dragging your mouse cursor. So testing with VoiceOver on the desktop, as well as using the Accessibility Inspector, allows you to hear what the UI sounds like, that is, the oral experience. And while you're testing and going through various aspects of your app UI, remember the 3 questions. What is this thing? What happens when I click? And were my expectations met? So let's switch back over to Android and testing in the Android emulator. So if your native app is running in the Android emulator, you can run the TalkBack screen reader directly in the emulator for testing. However, TalkBack is not installed by default. You can install TalkBack by logging into your Google account in the emulator and install the Android Accessibility Suite from Google Play. So refer back a few slides for more details, but as a reminder, starting TalkBack may differ slightly depending on the Android simulator. For Google Pixel-based simulators, you can go to Settings, Accessibility, and then click the Use TalkBack Switch control. And there's a few ways you can use TalkBack in the emulator. One, you can pinch zoom and swipe in the Android emulator by holding the Command key and clicking and dragging with your mouse. Another way is content discovery can be done in one of 2 ways. One is you use the mouse pointer to click and hold, which is a long press, and then drag the mouse pointer across the screen. So this is the same as using the explore method on an actual device. And the other method for content discovery is to use the mouse to swipe through the content. So I found that this works, sort of some of the time. This is more of a little bit cumbersome than on an actual device and may lead to unexpected results. So if you can, it's better to test on a real world Android device. Okay, so far we've learned what to watch for in terms of identifying accessibility issues. And that is the three questions. What is this thing? What happens when I click? Were my expectations met? We also learned how to test with mobile screen readers in iOS and Android devices, as well as discussed basic testing within the iOS simulator and Android emulator while working on our apps. So how does this all come back into play for React Native apps? So to help address accessibility issues in React Native, you can look to the React Native Accessibility API. So this API includes a series of React methods and props to provide things like roles, name, state for interactive elements. It also includes other items to increase general usability of an app while using assistive technology. So if you're at all familiar with HTML, the DOM, and the area spec for the web, then you've got a good start on understanding and how to use the accessibility API. The API documentation is available at reactnative.dev/docs/accessibility. And during my time working on COVID Shield, I didn't have a chance to explore every option of the API, but I'll go through and share what I did discover while working on the COVID Shield app. Okay. So let's start with a theme we've discussed a few times already, adding a role, name, and state to clickable elements such as a button. So while reading the accessibility API, I noticed that React Native provides a generic button component, which outputs markup to mimic a native HTML button element. So this component is a good choice when loading new views in the app or for other actions like submitting a form. However, in my experience with the COVID Shield app, the team decided on a different approach. In order to make the app appear more native for each platform, a custom button component was created for use within the app. So this component included some logic to generate platform-specific touch controls. For example, iOS devices would receive the touchable opacity component, and Android devices would use the ripple component. So the issue I found with these components was they did not include a role to help convey what the clickable thing was. So how do you add a role in React Native? In React Native, adding a role to provide context on the current thing the user is interacting with is a matter of adding the accessibility role prop. This prop is added to the component, which receives the click event. So this prop takes a string value, which is defined by the API, one of which is the value of button, which denotes an action will result upon activation. In HTML, this is similar to adding the role attribute to an element and assigning it the value of button. So the screenshot here shows the COVID Shield app with a visually styled button with the name enter code. Without the explicit role declaration, I found that there was only a sort of blip sound when the control came into focus by the screen reader. So nothing more was indicated to give a clear interaction or to give a clear meaning of what the thing was that I was interacting with. So after the accessibility role prop was added with the appropriate button value, the control was then described as enter code button. So another issue I noticed while testing, there were a few clickable elements in the app that only used icons to provide a visual affordance. So not only were these controls missing their role, they're also missing an accessible name to provide details on what it was they were meant for, their purpose. So the screen reader would stop on the control and not announce anything. So again, as a sighted user, I had the visual affordance of the icon indicating the control's intended purpose. But without a role and a name, a screen reader user would experience a seemingly unnecessary tab stop. So in React Native, adding a name to provide a sense of purpose for the current thing the user is interacting with is a matter of including the accessibility label prop. So this prop takes a string value, which is defined by the author. So be sure to include something that's appropriate for the context of the control. In HTML, this is something similar to adding the area label attribute to an element. And in the screenshot here, I have highlighted an icon control with a downward pointing arrow. This is meant as an indicator that this portion of the screen is collapsible. However, since there was no label or role, the screen reader would stop on the control and not provide any more information. After adding the explicit name and role, the control would then be described as close button. With this, the user would have an understanding of what the control's purpose was and be able to act on it accordingly. So moving on to control state. Around the COVID Shield app, there were some instances where controls were in a specific state. So in one particular view, there was a form with the submit control in a disabled state by default. So I knew this was disabled because as a sighted user, this information was communicated to me by the visual affordances of the design, the grayed out button with a dark gray text. A screen reader user, however, might not be able to acquire such information. Nothing was added programmatically, programmatically to provide the details on the control's current state. So in React Native, adding state information on the thing the user is interacting with is a matter of including the accessibility state prop. So this prop takes an object, which its definition and allowed values are defined by the API. In HTML, this would be similar to adding one of the many area state attributes. So for example, here, adding the area disabled attribute to convey a disabled state for a form control. In the screenshot here, I've highlighted a form submit control with the label submit code. It's visually grayed out with dark gray text, indicating it's in a disabled state. However, since there was no explicit state provided programmatically, the screen reader would stop on the control and announce its name only. So after adding the explicit state object with its value in the form of open curly bracket, disabled, colon, true, closed curly bracket, and including the role prop, the control would then be announced as submit code dimmed button. And in this particular example, the word dimmed is unique to iOS. Android describes this state as disabled. So let's discuss headings. That is typically large, bold text, which denotes the title of the page or a new section of content. So when testing COVID Shield, I noticed there were instances of larger, bold text that would appear throughout the app, usually at the top of a view. So in essence, this visual design conveyed the presence and structure of a heading, but the oral experience did not. So you may be asking, why? Why is this important? So it's important because when someone who depends on assistive technology, when they visit a new site or app, they'll often navigate first by headings. So people navigate by headings in order to quickly get a sense of the content being offered on the page. It's the same idea as someone scanning through and reading the headings of a news website or a blog post. The idea is to gather the general idea of the content available, then revisit the sections of interest. So how do you add a heading in React Native? So we can convey a heading by adding the accessibility role prop to the component which contains the heading text. And according to the React Native Accessibility API, the string value of header should be set for the accessibility role prop value. It's interesting to note that in React Native, we're not able to assign a heading level. So in HTML, we have the H1 through H6 heading elements, which indicate heading level and logical structure of content. But with React Native, it's strictly a heading only. So for the example here, the screenshot shows a COVID Shield view with a visually styled text heading with the content, share your random IDs. Without the explicit heading declaration, the screen reader would read the content as plain text. So it's not the worst user experience, but it's also not conveying the same experience as a sighted user would receive. So after adding the accessibility role prop with the appropriate header value, the text was then described as share your random IDs heading. Not only is the oral user experience describing the text as a heading, denoting a new section of content, screen reader users can also navigate by headings alone to gain an understanding of the page content. So let's discuss hint text. So hint text in the context of where I'll be using it is a method to provide additional information that is visually hidden from sighted users. So this scenario is also quite common on the web. The idea is if a link opens a new browser tab or window, or if the app control takes the user out of the current app, it's best practice to inform the user of this end result. So why is this important? Without this context, people might believe they're following an internal site link, which loads in the same browser window. Opening a new tab or the device browser on behalf of the user would cause extra work for our users to try and go back to that initial state. So the idea is to give power to the user. We want to inform the user of what might happen upon interaction in order to allow a choice to be made on how and when they'd like to proceed. So we can include a hint text by adding the accessibility hint prop to the component which activation results in the new context being opened. This prop takes a string value, which is defined by the author. So again, be sure to include something that's appropriate for the context. For this example, the screenshot here shows the COVID Shield menu highlighting a clickable control with the content check symptoms. Beside the text is an arrow icon, which is pointing up and to the right. The intention here is to provide a visual indication of the result. That is, you would leave the app and enter into a different context. So without the accessibility hint prop, the control simply read check symptoms. And after adding the accessibility role and accessibility hint prop with an appropriate string value, the control was then described as check symptoms, opens in a new window, link. So not only is the visual user experience increased by the icon, but also the oral user experience is enhanced by sharing the meaning behind the icon. As a result, all users will be able to make an informed decision if and when they'd like to activate the link, either now or later when they're ready. So we're coming up on time, but I have one more section to share, and it's actually quite important. This is the context, the concept of focus management. So focus management is a method to willfully and purposefully shift the keyboard focus cursor from one element to another on behalf of the user. So this technique is sometimes required to guide the user with the intended flow of the app. So for example, when opening a modal window, focus must be placed on or inside of the modal window in order to bring this new context awareness to the user. Otherwise, focus remains on the activator control, and the user may not be aware of or be able to easily reach the modal content. So in terms of COVID Shield, React Native, and really single page apps in general, a big accessibility issue lies in managing focus between views. In a traditional browser environment, the user would click a link or a button to submit a form, and a full page refresh would occur. So at this point, the user's focus would be placed at the top of the document, and they'd navigate forward from the top as expected. With React Native and other single-page app environments, this is not really the case. What typically happens is when a new view is loaded onto the screen, focus remains on the previous activator control. Now, the problem here is two issues. One, on click, there's not really any notification provided to a screen reader user that the new view has been loaded. Focus would remain on the control that they previously clicked. And number two, when the user eventually tries to move the cursor, there's no telling where it may end up. It could go to the top of the new view. It could go someplace in the previous view. So this is why intentionally moving focus is very important. So how do we handle managing focus between one view to the next? So there's a few different approaches that you could take when managing focus between app views. One could be that you could shift focus to the view container, that is the top of the view. This would allow the user to navigate forward as if a full page refresh had taken place. Another example is you could move focus to the top level heading element. And this would allow the user to move forward from this point. So these are a couple of potential solutions, but instead of speculating, let's review some data from a study done in 2019. So this study was conducted by Marcy Sutton, an independent web developer and accessibility subject matter expert who was working with the Gatsby team at the time. And the purpose of the study was to find out which approach rendered the best, most positive user experience for a number of different disability groups using various assistive technologies. Specifically, the study included sighted keyboard-only users, screen reader users, low-vision Zoom users, and voice dictation users. So you should definitely read through this post when you have a few minutes, but I'll jump to the conclusion as to what was considered a pretty good solution for some, but not necessarily the best for all. And I'll share why. So the idea is that the ideal situation is to shift focus to a heading. So this was one of the more successful solutions that worked for mostly all user groups. Shifting focus to a heading is a good solution as it provides screen reader users with a clear indication of what happened after the view loads. It announces the heading text, and focus shifts from the previous control to the new view. For voice dictation, keyboard only, and Zoom users, shifting to the heading orients the user to the new starting point in the app. Although ideally, when the heading is in focus, it would include some sort of visual focus indicator, such as a focus outline. And if no outline is present, some sighted assistive technology users may have a slightly more difficult time with understanding where the cursor is currently focused on. But overall, it's in a much better place than if we hadn't shifted focus at all. So all that said, how do we shift focus to a heading in React Native? It's a good question, and one I'm afraid I don't really have a good answer for. So this is one of the issues I reported and suggested to move focus to the view heading, but the COVID Shield team at the time didn't have time to address this. So instead, what we can do is take a look at what the COVID Alert app does. So reviewing the app source code on GitHub, the Canadian Digital Services team created their own accessibility autofocus prop. So this prop was placed on the heading text component, and when the view loads, focus shifts to the heading. So for the example here, the screenshot shows the COVID Alert app running on an Android phone. The heading text, enter your one-time key, is highlighted with a green border indicating the text has focus and is announced by the talkback screen reader when the view loads. So there could be other solutions out there, perhaps a another third-party component you can incorporate into your project. Or depending on how your project is structured, you could simplify things by using a React ref with the component did mount lifecycle method. But definitely check out the accessibility autofocus solution on GitHub from the COVID alert app. It works very well. Okay, so everything we've discussed today has mostly catered to the screen reader user experience. And while addressing issues for screen readers does help to remove a lot of barriers for other assistive technologies, such as keyboard-only and voice dictation users, it shouldn't be the only focus. So iOS and Android have many other accessibility features built in. Here's a few other areas to try out next time you're testing for accessibility. So font size. Make sure your app's text is able to be dynamically adjusted according to the operating system settings. This helps folks with low vision to be able to read content with ease. Color inversion. This also helps people with various visual impairments. Test to make sure your content is still legible when colors are inverted. And the reduced motion setting. If you've got lots of animations or movements on the screen, some people prefer little to no motion, as they may be prone to motion sickness or other vestibular issues. So you'd want to use the prefers reduced motion CSS media query to take advantage of this setting. And these are just a few settings available. I definitely encourage you to explore each setting and learn how you can adjust your designs to be more dynamic in order to be more inclusive for your users' needs. Thank you very much.
Awesome. Thank you so much, Scott, for a great session. We do have about 7 minutes for Q&A. Thank you all for adding your questions in here. I'm going to get through as many of them as possible. If you could help to upvote the questions, that will help me to prioritize on getting to the ones that y'all want to hear answers to the most. All right, so let's dive in, Scott. Okay, how do you feel about landscape mode for mobile apps? It's mandatory for organizations who need to comply to WCAG, but very few apps support landscape mode.
Yeah, that's a good question. I suppose do your due diligence in testing out to make sure your apps support landscape mode well. And if it doesn't, contact your designers, contact your development team, and let them know. As the person's question states, it's required by WCAG, so go for it. Absolutely.
Thank you very much. Okay, next question here. What are your thoughts on RN for web? IME, the accessibility models of web and native are largely incompatible, which leads to needing different implementations. What are your thoughts on RN for web?
Wow. I'm going to be completely honest. I don't know what that is. I'm assuming it's you can create React Native apps which work in the web browser. Incompatibility. Yeah, that's going to be tough. Essentially, that's going to be creating more environments for people to have to do more testing.
Gotcha.
Yeah, I'm not familiar with that technology, but that's interesting. I'll have to look into it.
For sure.
Yeah.
All right, let's see a couple more questions here. Do you use accessibility hints as an extra to accessibility labels? Accessibility Inspector seems to lack support for this.
Yeah, so the hinting specifically may not necessarily come through in the inspector. It may not even necessarily come through when you're testing with VoiceOver on desktop. Hinting really is a bit of extra text that is applied after the fact to the control in question. I guess use it in good judgment. Is not necessarily the thing that you need to reach for all the time. Most of the time you could include all the information that you need within the label prop itself.
Right.
But yeah, use your best judgment. You do your testing and yeah, use the tools as needed.
Great. Thank you, Scott. Okay, Michael is asking, why React Native? Are there any benefits to using React Native over other cross-platform frameworks for accessibility?
Great question. I honestly don't know. our Shopify leads decide on React Native, and this is what we're using. So this is what I'm working with. And thankfully, like I mentioned earlier, the React Native team has put in place this really awesome API that we have available to us to help address some of these issues. So
right.
it's there's still a really good chance that if you're using React Native, you can make really high quality and highly accessible experiences by default.
Definitely. Okay. Would you say providing accessibility actions for things like visual swipe right to delete are a good practice?
That's actually come up recently. Actually, no, it wasn't recently, but it came up at one point on a project I was working on with the team here at Shopify. They wanted to implement a visual, I guess, indicator when someone is using the arrow keys. Specifically, this is coming back to the 3D model implementation that we have. And I was looking at it, I thought it was an interesting take, but I just asked the question, why? What does this actually serve? If someone is able to see this indicator while they're interacting with the thing using their keyboard, that they already have no awareness of the keys that they're pressing,
right?
Which is my take. And I don't really think that's a visual like that is necessary.
Gotcha. Thank you. I think we have time for maybe a couple more questions here. So again, if you haven't yet, please upvote the questions so we can grab the final one or two here. Focus for web is used to describe highlighting interactive, not static content. In apps, we use it interchangeably. Should we still call it focus in apps?
Not sure if I follow the question. You mind repeating that again?
Yeah. So focus for web is used to describe highlighting interactive or not static content. In apps, I'm assuming mobile apps, we use it interchangeably. Should we still call it focus in apps? So it sounds like focus is being used in multiple ways.
Mm-hmm. So the word focus for web, is that a technology? I'm not sure. I'm not sure what that is.
Focus. Just the word focus.
Okay. Yeah, I mean, you can get into the semantics of words, and like there's a big question that went around recently about the word disabled, using the word disabled to describe a control in a disabled state. It sort of is what it is. I kind of feel like if we were to start changing these things, it might be confusing for developers. The HTML spec might need to be rewritten in some regard. So I think it's known that what focus means is to manage focus, to switch between one thing to another. So I think it's fine.
Gotcha. Awesome. Okay. Just one last question here.
Mm-hmm.
Do you have any suggestions on accessible components designed with React, like carousels, cards, or accordions? Suggestions?
Yeah. That's a great question. I'm sure they must exist. I haven't done a lot of research into this myself. A lot of what we build in-house is all custom, as I've shared.
Right.
And because of that customizable sort of approach, we have to do our own testing and make sure what we create is accessible by default. I would say if you're going to do some researching, and if you find something that claims to be accessible, you have to do your own testing to make sure it's actually solid. I've found that in the past where I would implement a component that makes the claim that it's accessible, and I do some high level testing. It's just not. So you really have to be careful, especially, when someone has good intentions of making something accessible, maybe they don't necessarily understand the spec and what the expectations are for people with disabilities. Do your own due diligence, have it tested, and even go into, if you're able to, have it tested by an actual person with a disability, and run some usability test sessions with folks. It's super important to get that feedback, and it's something that we incorporate often here at Shopify.
Absolutely. All right. Well, with that, we are at time. I want to say thank you, Scott, for a great session, and thank you all for attending. We hope you enjoy the rest of AxeCon. Have a good day.
Thanks, everyone.
Thanks, everyone.